Start recording. All right. Good morning, folks. Right. You can hear me, see me, right? Yes, yes. Nod. All right. So, yes, I did finish up grading your tests and looking over your scratch work. Gave back a few points here and there. You might say the test program just marks it wrong, completely wrong, if you don't get exactly the right answer. So then I go in and look at your scratch work, and sometimes I'll give you, 2 out of 6 or 3 or 4 out of 6, depending on what kind of mistake you made. A little mistake in the problem. And the flip side of that is, in general, if you don't show me any work, you're only going to get a half the credit. How did you get that answer? Okay, so I might knock a few points. I didn't have to do that this time, but just want to mention that. Folks usually ask me about grades. Folks usually ask me about grades at this point. This is a pass, no pass class. So you have to have overall a 70% average, plus you have to get a 70% on the final. So there's like 2 different criteria: overall 70, and that specific final exam you have to pass that final, get a 70%. And just a reminder, see, the discussion forums are 10%, no, I think 5%. 5% of your grade, and to get that full credit every week, you need to post twice during the week. And preferably, I've been basically accepting any post that you've made at this point, but it'd be nice to see a little more discussion or, worthwhile posts. I don't know. I think you get the idea. But anyway, yeah, tests overall were pretty good. That is, almost everybody got a reasonable grade. Let's put it that way. I don't want to get into details there. All right, but now we're starting in chapter 2, and up till now we've been talking about pretty much kind of all the building blocks, the number systems, variables, expressions, how to combine and simplify those expressions. And now we're going to work with those expressions, and what does that expression mean, or how's it used? It can be used to describe situations out of the real world, or even abstractly, and solve an equation built out of those expressions, find an unknown value if we know the relationship. Eventually we move towards what we call equations in 2 variables. The final outcome is the result of some expression that we have, and so we don't know what the final is until we put something into the other expression. And so we get, this one depends on that, and you can graph those, look at the relationship. They'll all be what we call linear, or lines, in this course. They get more and more complicated as you get through more and more complicated situations, but we'll just deal with that kind eventually, chapter 4 and 5. Solving equations. We have, looks like, a lot of sections we're going through here in the next 2 days, 2.1, 2, 3, and 4. It's because they're really all so closely related. They start with simple expressions and build up to those things where you have to distribute a bunch before you can finally get down to the final answer. So I kind of, we can get through them all together if you understand those concepts and you're okay with that sort of simplification process that we've already been doing with our expressions. So just to start out with, my statement here, or typical statement for an equation, is a statement, like a complete sentence, that claims that 2 expressions are equal. Up till now, we really haven't worked with equal signs. So now we're going to get things that say this relationship, 5 more than twice a number, for instance, like on your test, is equal to 3 less than 5 times a number. Now, what's that number then? If we've got this relationship that this amount is supposed to equal that amount, well, what's the number that makes it true? That's a little more complicated than we'll start with. But a solution, we're looking for solutions. Solutions of value for the variable that makes the equation true. That makes the equation true. Okay, so we're looking for solutions. What's that value for the variable that makes that relationship statement true? Just as an equation, I could say, 8 equals 2 times 4. Now there's no variable in there, but is that a true statement? Well, yes. So that's a true equation. I could write 5 equals 7, and that's a false one. So however I got there, that one wouldn't be solved. Okay. So in general, we're looking for values for the variable that will make this relationship statement true. That equal sign, my little balance drawing up here, sometimes you see a teeter-totter, can be thought of as the center of a balance. And to start with, it says that this side equals that side. And if I change something on one side, it affects the other side. And so if I change something on one side, I have to similarly change it on the other side. That's going to be a basic a technique or approach. Whatever we do to one side, we're going to have to do to the other side to try to get where we're trying to go. Okay. So, well, there's big picture there. So I'm going to erase all this. All right. As always, slow me down. Just a minute. You need to. Here it goes. Here's an example of type of equation we're going to start with in 2.1 and look for solutions to that equation. To begin with, we'll be asked to verify, is a certain value a solution to that equation? And we'll be given a couple values to plug in for the variable, and then we sort of evaluate the expression like we did previously. Plug in that number and see if we get a true statement. So if x is a 3, I get 3 plus 5 equals 8. 8 equals 8. Yep, that means that one's a solution. If x equals -2, I get, 3 equals 8. No, there's not equal, right? Cross it off. That's not true. So this one is not a solution, right? Not a solution. So that's the basic verification process. You'll be given an equation, right? Somehow or other, this expression, quantity we might have generated last chapter, it's supposed to equal an 8. What's the number that makes it true? Here, if we know a number to test, plug it in. First concept, let me know if you need more of that. I'm gonna keep going here. All right, so we end up sort of manipulating these equations, because if I just have a statement that says x equals 5, oh, okay, that's an equation. That's telling me that that variable equals the number 5. And that's really the form that we want to boil these equations down to, get to a final statement that tells us what that value for that variable is. But of course, they start more complicated and we kind of have to manipulate them to get to that point. We're going to use the basic operations that we practiced in last chapter: add, subtract, multiply, and divide, to turn that more complicated equation into something that looks like that form. So to begin with, we start with adding and subtracting. In the last chapter, I think it was about 1.8, we talked about properties, maybe at 1.9. We talked about properties of the number system. And we talked about every number having an additive inverse. And those were two numbers that added up to 0. And I made the claim this is going to be something that we sort of use in equation solving, even if it's kind of in our head. right? If I can get two numbers to add up to 0, cancel each other out is how we'll kind of talk about it, then I've kind of gotten rid of it, all right? So we're going to use this additive inverse property in this process of adding and subtracting to get down to that final form. So just starting with here's an example. We have our variable and something is added or subtracted to it, 9 less than a number, and that's supposed to add up to 20. Well, I want to eventually get down to just x equals something. So if I just have something added or subtracted, I want to use its additive inverse to turn that into 0. Now, so what's the additive inverse of minus 9? It'd be add 9. So I'm going to write this two different ways, because one is the way mathematicians would present it, and the other way is the way you might prefer to do it, say if you're doing it on paper. So this is what started, and I want to get that other number in there that's going to make this turn into a 0. So I'm going to add a 9. Well, here's my balance, right? If I add 9 here, it's out of balance. I have to add 9 on the other side. That's the big deal. Always do the same thing on the other side. All right, now here's the step that probably won't have to, you don't have to really show anymore. But those two turned into a 0. That was the additive inverse property that we used. And what that identity element, right, for addition means it doesn't change the x. So really we just get to ignore it and say x is 29. I don't expect you to show me this step, but this is what we're doing, right? Theoretically, you might say. We're getting to cancel those out so that there's only 0 left there. So we can say that means the x must be a 29. You can always go back and check this, plug it in and verify. If x is a 29, does that give me a 20? Yep, 20 equals 20. Here I had something subtracted from my variable, so I do the opposite operation of subtracting. I added something. We're thinking about a lot. What's the opposite of that operation? Because that's the other thing you want to do to change it and get rid of that thing. Okay, here we go. Keep going. Same idea. This variable has 12 subtracted from it, and that's somehow supposed to end up as a 5. Well, how do I get the x alone, is what I might say. You know, how do I figure out what that x value is? If I've subtracted 12 from it to get 5, I want to do the opposite of subtracting. I'm going to add 12. Oh, I said I'd write that two different ways. I'll be sure I do that on this one. Okay, so I added the 12 to both sides. That makes those two a 0. Are you okay with me just saying x equals a 17 then? I didn't show the 0 step. You could do yourself right here and say, oh, that gets me the 0. You'd like to have that in your notes. That's funny looking 0, it's a pendant. The other way, I mentioned a lot of folks kind of like to do it this way. Oh, I'm subtracting here, so let's do the addition like that, right? Negative 12 plus 12, and I get x plus 0 equals 17. So that's sort of like the vertical arithmetic method. Otherwise, mathematicians tend to write everything very orderly horizontally. This will be okay in your scratch work as long as you're real careful, know what you're doing. All right, keep going. Did I finish that one? I did. I made a mistake. Did I make a mistake? No, I added 12 to both sides. Oh, okay. Thinking, had something else in mind, and it wasn't that problem. All right. Similar kind of problem in those last couple examples. Something was subtracted from my variable, and so adding was the opposite. This time I have something added, 5 more than a number. Something added to the variable, and so to cancel out the addition, I'm going to subtract that number. Subtract the same exact thing, right? Use its additive inverse. Making sure nobody's out there waiting. And have to do it on the other side. You probably do this one in your head, say, oh, I know what x must be, but we're talking about a process as they get more complicated, right? These two turn into a 0. So I get x equals 4. Again, you do it like that. Just be real careful, be neat. Right? There's no real equal sign in there. Just like I subtracted 5 on this side, and I subtracted 5 on that side. Doing it again. This one says the 6 more than a number equals 2. 6 more than a number. I'm kind of trying to use that expression translation there. 6 more than a number is 2. Is will be the equal sign. We get to those translations. We have to do those again with equations. Well, what's the opposite here? I'm going to subtract 6 from both sides. If I subtract that 6, this turns into a 0, and I get x equals 2 minus 6, a negative number. It can happen, definitely. All right, you're going to get the whole range of integers, positive, negatives, fractions occasionally. We tend to stay away from the fractions while we're presenting the concepts, but then eventually we'll mix in some fractions. You know, got to be able to do these operations with some fractions too. All right, let's see. If I say, can you just do that one yourself real quick on paper? Maybe not real quick, I shouldn't rush you, but little, you know, we take 30 seconds if you understand the concept. You're going to do the opposite thing here, change both sides, and I get 15. Did you get 15? If you don't get 15, let's figure out why, okay? I added 4, right? I added 4. All right. And, well, how about let's do a fraction, okay? It's going to happen. It's just happens to be messier numbers, you know, but we're going to do the exact same thing. Well, this variable, 2/3 less than a number, okay? 2/3 is a constant, right? It's not a number of x's or anything. 2/3 less than the number. So the opposite of subtracting, I'm going to add 2/3. Now, when looking at it with fractions, it really is kind of helpful to do it, especially in this case, because I can't just add these vertically. I'm going to have to do a little common denominator thing over there. So minus 2/3 plus 2/3, they go away. So x is whatever I get when I push these two fractions together. Right? Not too complicated, I hope. Common denominator is 6. So times 2 times 2. 5, 6 plus 4, 6. And now combine those. X equals 9/6. I was already thinking about dividing it by 3. My hand does that. 9, 6. But yes, it's not lowest terms. All right. I could divide both of those numbers by 3. And that's the same as 3 halves. Okay. So same process, doing the opposite operation to get where we're headed, where we want to get to. All right, there we go. Now, the textbook problems, these are kind of made up a little bit to be, well, find ways for you to have to simplify a little bit before we do what we're going to do. All right. X, some variable plus a 31 minus 10. For some reason, we are adding a number and subtracting a number, and that's supposed to equal a 46. Combining like terms, that's what this is about. Simplify as much as you can, right? Before, to boil it down to that, well, one more step left. So here I'm going to combine 31 minus 10 and get x plus 21 equals 46. And now it's just like the last few that we've done. Well, to get this x alone, the opposite here would be to subtract 21. 25 is the number that should work. Again, you can always check, go back and plug it in, see if it works. Is it really true? You can verify that answer. There we go. Here. And let's do something this silly here, like just similar idea. Let's simplify before, as much as we can before we get down to that last step. Well, let's see, how many x's in this first section of the text anyway? It always boils down to just one. 6 x's minus 5 x's means I only have 1 x. Here's the constants, 8 plus 16 means I have 24. So this variable plus 24 gets me to 32. Doing the opposite operation is to subtract 24 from both sides. They balance. So 8 is the solution, the value that makes that weird original relationship true. All right. Can you write an equation for me? 9 more than a number is 12. Is will be your equal sign. Sometimes are, the plural, gets used, but that is. That all this stuff is something. So that's where your equal sign is. So we really kind of have 2 expressions. 9 more than a number. That's an expression. 12 is an expression. Standalone number. So for translating, 9 more than a number. More than plus 2 is a variable. That's what I was after. Don't care what letter you use, unless, watch out, mom might tell you to use a certain letter. And then might ask you to solve it. Subtract the 9, get a 3. Huh? So some translating like that you'll have to do. I just made up something a little more like a word problem at this level. Amy is 3 years older than Jim. If Jim is 25, how old is Amy? Now, that one you might just do in your head, but let's write the equation. Let X, what are we looking for, right? What are we looking for? How old is Amy? That's what we call our variable. What are we looking for? Let X be Amy's age. All right, so defining a variable. Define a variable. And now we build an equation, part of the relationship presented here. Amy age is, all right, oh, Amy is 3 years older than Jim. If Jim is 25, well, this is kind of weak the way I wrote it. X is 25 plus 3. Well, that works, right? So Amy must be 28. Amy is 28. Complete sentence. All right, watch out for that come test time. If you get a question like this, though, you'll be asked to present your answer in a complete sentence. Pretty short, but it's a sentence. Subject, verb. All right, so just again, your is. I might have made it trickier and said, 25 is 3 less than X. I could have, you can see how this, I might have said 25 is X minus 3, and then I would add the 3 to both sides. So there's more than one way to write that. Somehow it had a problem with mom where people would write this and maybe mom really wanted a complicated one. Something like that happens, send me the email. I don't like that. I'll go in and fix it for you. Okay. That's okay, I'm gonna keep going. Here we go. All right, that's 2.1. Add and subtract. Changing my notes a little here, and number 2.2. Is it all? Everything out of order. Oh. I don't need it. 2.2, multiply and divide. Solve equations by multiplying and dividing. Again, referring back to that 1.8 section where we talked about properties. If I had some number, it had a multiplicative inverse such that if I multiply these two numbers together, I turn it into the multiplicative identity number 1. I multiply by some number, which was always its reciprocal. And if I multiply them together, I get a 1. And here I made the claim that's going to be valuable in our equation solving because 1 times something is just the something. And like the 0 previously in add subtract, if we have 1 times a something, we ignore the 1. It's just the something, the x. 1x is just x. So we're going to use this multiplicative inverse property to sort of cancel out, undo multiplication and division. So we reduce our variable number, how many variables, to a 1. So here's an example of some kind of problem, that kind of problem. Here we have our variable and it's divided by 5. And somehow or other, however this expression came to be, if you divide that quantity by 5, you end up with a 3. Well, I want to manipulate, boil it down to x, plain old x, 1x equals something. Well, I'm going to use the opposite operation of dividing, which is multiplying. And it's kind of nice when you write it like this as a fraction, because multiplying by that same value, right? Multiply by its reciprocal is going to allow those 5s to cancel out. Do it on the other side. I multiplied by 5, I've got to multiply by 5. Keep it balanced, just like made everything proportionally bigger, all right? The 5s go away and I get a 1x equals 15. And here's what I was getting at. You could ignore the 1 and just say, yes, that means x equals 15. Again, if I put that 15 in the original, 15 divided by 5, yes, I can verify that gets me that 3. There it goes. You're not going to see the division, arithmetic division symbol, I don't think. We're going to, from now on, pretty much fraction form for dividing, okay? Algebra, not arithmetic. Oh, boring, -3, whatever. 3 is the top of the head, just making up numbers. Same situation. The variable is being divided by 11, all right? 1/11 of this number is a -3. How do I get to that original number? I'm going to do the opposite of dividing by 11. I'm going to multiply by 11. So 11 times x over 11. Do it on the other side, or else. And, you know, make it look like a fraction you want. But that allows the 11s to cancel out to a 1, basically. It never cancels to 0, right? We dividing by something, we always get to a 1. It didn't just become nothing. I see that sometimes is why I mention it. So now x equals, don't lose your negative sign. Almost like I say that, and I know somebody will do it. It's very unfortunate. You make little mistakes like that. I'll throw out little things like, yeah, I saw a couple of those on the test. It's unfortunate. I usually gave you back a good deal of that credit, though, if you just forgot, you know, especially if it was on your scratch paper and then you didn't put it in the program, you got most of that back. Don't lose your negative sign. Okay, so here we divided the variable. The opposite was to multiply. Well, do the other way around. All right, 7 of these variables is 28. If I buy 7 items, it costs me $28. How much did the item cost? It's kind of the context we could apply here. Well, here the variable is being multiplied by 7. Excuse me, its opposite operation is to divide by that exact number. So here I'm trying to show better form than that very first one, where it's really best to start with the problem and then go to the next step to show your work. Do it to both sides. 28 divide both sides by 7. And there gives me that 1, right? And if you're lucky, you'll get integer values. 28 divided by 7. Make my life easy. You've got a whole number 4. Do the inverse, multiplicative inverses. Another way, how about I write it this way too? Right, dividing by 7 is the same as multiplying by 1/7. That notation, flexibility, might come in handy sometime. Okay? 15 of these things equals -75. What's that thing? Opposite of multiplying by 15 is dividing by 15. Don't lose my negative. 15 over 15, that gives me the 1. Don't lose my negative. 75 divided by 15. That's a nice one to sort of get familiar with. That's 5. Nice whole number. Integer, actually, not whole number, negative. Okay. Yep. And I did want to find, yeah. Really try to, mix it up, make you simplify a little bit, right? Oh my. Okay. If we put these constants together, like terms, and we put all those variable expressions together, like terms, then we get something we can do one of our add or subtract, multiply, or divide operations to. So minus 18 and minus 7 more, negative 25, positive 5, and 5 minus 9 minus 6. So this one gets me to negative 4 and negative 10. Right? How many x's? We refer to that number as the coefficient. It's kind of a funny word, but the number that multiplies your variable. They're all the same variable, so we can combine those numbers using our arithmetic. All right, now the x just happens to be on this side. It's okay. Something equals x, that's fine. If you're really uncomfortable, you can flip it around and say negative 10x equals negative 25. So here, the x is being multiplied by negative 10. Good example because I haven't done one with a negative number on the variable. But the inverse, to get it to cancel to 1, I'm dividing still by the exact same number, which is negative 10. I need to include the negative, so I have negative divided by negative, leaves me a positive x. Same thing on the other side. All right. So here, they cancel and I get just x. Here, negative, negative, and I'll do the long, I get 25 over 10, but that's not lowest terms. I can see that both of those still can be divided by 5. So dividing that by 5, I get 5. Divided by 5, I get 2. So 5 halves would be the lowest terms answer. Always expect to go to lowest terms. Again, saw a couple unfortunate errors. Folks did everything right on the test and maybe even simplified a little bit and then didn't recognize there was a little more simplifying you could do. So, out of 6 points, you lost 1 or something like that. All right, so that was, simplify before you can perform the sort of the final inverse operation. Inverses, add and subtract are inverse operations, opposites. Multiply and divide are inverse operations. Fractions. Well, this variable is being multiplied by 3/5. It has a multiplicative inverse, the reciprocal, multiplied by its reciprocal to cancel out the fraction. So here's the original, multiplying by its inverse. I could write it on the other side, right? It's multiply, multiply, multiply. But usually we're more comfortable seeing it right next to each other like this. And make sure you do reciprocal, not the original. Some dumb mistake I make sometimes. On the other side, right? So flipped it over to multiply by its reciprocal. That's its multiplicative inverse. The 3's cancel, the 5's cancel. That's 1x. And over here, well, I made up some numbers and there's nothing to simplify at this point. 35 over 24. There were no common factors. That's a lowest terms answer. Just like that. How about, $187 is the product of 17 times a number. Find the number. Write an equation. Is still equals product. What operation does product describe? This is multiplication, of course, in our current chapter, right? Write an equation. Well, two expressions really, 187, kind of standalone expression. Here's the other expression, the product of -17 and a number. I maybe should have wrote product of -17 times a number. That's almost redundant, right? -17 times a number. A number, you know, choose a variable. Unless mom tells you to use a certain one. So there's the equation I get out of this. And now, well, to undo the -17, I'm going to divide by -17. That gets me positive x. And I think I can see how 17 goes in 18 once, leaves a 17. I'm pretty sure that's an 11. 11 times 17. Calculator will help you there if you're not sure. And then don't lose your negative sign, right? -11. So a similar kind of translation situation where we're trying to create the equation. Even if you think you can do it in your head, practice writing down an equation that describes what you understand you're going to do. Practice writing an equation. Okay? How about, really, I've gotten through the content of 2.1 and 2.2. If we continue, as we continue tomorrow with 2.3 and 2.4, they're just going to use the same operations. We're just going to have to simplify more. I think 2.3 says equations with variables on both sides. It means we'll have some x's and constants on one side and on the other side. So we kind of have to get them all, you know, separated. Let's put all x's on one side and all the numbers on the other side using these same plus minus operations. 2.4, a little more of let's distribute a bunch and then simplify. So they're just getting a little more complicated. The work we have to do before we can get down to this last couple operation steps here. So how you feel about this so far? You know, this is 2.1 and 2.2, and that's those two sections are together as the first homework assignment. I encourage you to go in there while it's fresh and give them a try. And I always say, don't wait till the last minute. Right? And if you're having any questions, difficulty in seeing your test grades, I believe are visible right now. You can go in, I believe, to your test and actually it'll show you what the correct score should have been. I don't think it shows you any work. If you really need to, I mean, you have your own scratch work. Maybe you can go back and figure out how you're going to supposed to get that answer. If you really have some question about what I do wrong, send me a message and I'll try to reply to you personally, okay? Otherwise, I think we're done for today, all right? Add and subtract, solve those equations. All right, folks, well, then I'll see you tomorrow, same time, same place, okay? All right, bye, thanks, yeah.